Hi everyone, welcome to a new video. In this video, we will learn how to compute the determinant of a matrix. So normally for a matrix A, the determinant is denoted by A inside two vertical lines. And don't confuse this. This does not mean the absolute value, but it means the determinant. The other also notation used is this determinant of A. So both of these are common notation to denote the determinant of a matrix. So before going into the calculation, two key points about the determinant. First, the determinant of a matrix is a real number. And the other thing is that the determinant is only defined for square matrices. So for a matrix 2 by 2, 3 by 3, 4 by 4, but it's not defined for a matrix like 4 by 5. Now let's go to the calculation. Let's start first with the simple cases. Let's take first the case when you have 1 by 1 matrix. And for this case, the determinant is simply the number, the element of that matrix. So for this case, for example, we have one element, which is 3. So the determinant of this matrix is 3. If you have something like -5, the determinant of A is -5. Again, don't confuse this notation. It's not the absolute value, but it means just the determinant. So as you can see, we didn't remove the sign. The element is -5, so the determinant here is -5. That is for the case when you have 1 by 1 matrix. Now let's look at the case when you have 2 by 2. So if you have a matrix like this, A, P, C, and D, this is 2 by 2. The determinant of this matrix, you can calculate it as follows. You multiply the elements of the main diagonal, A times D, minus the two other elements, C times P. Example, say you have A, 1, 3, 5, 4. So the determinant for this matrix is you multiply elements in the main diagonal, so 1 times 4, minus the other two elements, so that is 5 times 3. So this gives us 4 minus 15 or minus 11. So this is how we do it for 2 by 2. Now, for matrices that are larger, say for 3 by 3, 4 by 4, we need to use what's known as cofactor expansion. So first, let's understand what do we mean by cofactor of an element. Cofactor of an element of a matrix. So let's have an example to illustrate this. Say you have this matrix 1, 2, 3, 4, 1, 2, 5, 0, and 3. So each one of these elements have a cofactor. For example, we can denote the cofactor 1, 2. This means we are looking for the cofactor for the element in the first row and second column. So we are trying to get the cofactor of element A12. That is the element in the first row and second column. And the way to calculate this is as follows. We have this coefficient -1 to the power of the sum of the row and the column. So the row here is 1 plus the column. And then we create a determinant which is formed by eliminating the row and the column in which this element is located. So we have to delete, in this case, the element in the first row and the second column. So we have to delete the first row and the second column. The remaining elements are 4, 2, 5, 3. So this gives us a determinant, and then -1 to power 3 gives us -1, and then we can expand this 2 by 2 determinant as we did before. So 4 times 3 minus 5 times 2 equal to -1 times 4 times 3, 12, 5 times 2, 10. So this 12 minus 10 give us 2, and then multiplying with -1 will give us -2. Let's look at another example. Let's say we want to get the cofactor of the element in row 1 and column 1. So again, we do the same thing. We have this coefficient -1 to the power of the sum of the row and the column. So 1 plus 1. And then we have a determinant that we get by eliminating the row and the column in which this element is located. So this element is located in row 1 and column 1. If we eliminate these, we will left with 1, 2, 0, and 3. So we compute this. -1 to power 2, that give us 1 times, we calculate this 2 by 2 determinant, 1 times 3 minus 0 times 2. 1 times 3 is 3, and 0 times 2, 0. So this gives us 3 minus 0, or 3 times 1 give us 3. So this is the cofactor. So then the determinant actually can be calculated by picking any row or any column, whatever row and whatever column you want. And what you will do is you take each element in that row and column and you multiply it with the cofactor for that element and you add these. So for example, let's say we're gonna pick the first row. So if I pick the first row and I want to calculate the determinant of the matrix, what you will do is you will take element 1, 1 times the cofactor for that element, which is C11, plus the second element is 1, 2 times the cofactor for the same element, 1, 2, plus A13 times C13. Okay, and then you calculate this. Normally, for calculation purposes, it's actually much easier just to put the sign directly on the row that you are trying to use or the column that you're trying to use. And then what you will do is take the element with the sign and you multiply it with the determinant that you get by eliminating that element. Let me illustrate this. So let me again write the matrix that we just have above. So we have A, 1, 2, 3, 4, 1, 2, 5, 0, 3. So this is the matrix that we have above. As I said, for calculation purposes, might be easier just to put the sign directly on the row and the column that you are using. So the first element always here is positive. This is positive. Then the sign alternate. So if you are using, for example, the first row, the next one will be minus, then plus. If you use the first column, it will be minus, plus. If you want to use the second column, for example, the top one is minus, so the next one will be positive and negative. So let's illustrate this by using the first row first. So the determinant of A, if we are using the first row, we'll take the first element with the sign, so it's positive, it will mean 1 times, and then we get the determinant by eliminating the row and the column of that first element. So what you will get is 1, 2, 0, and 3. Then you go to the next element in the row and you take it with its sign. So this gives a minus 2 times. Again, we create a new determinant by eliminating the row and the column for that element. So this gives us 4, 2, 5, and 3. And then the last element, again, we take it with the sign that we have. So plus 3 times. Again, we create a new determinant by eliminating the row and column of that element. So what we'll have is 4, 1, 5, and 0. Okay, now we just calculate this. So 1 times the determinant, the first determinant here is simply 1 times 3 is 3 minus 0 times 2 give us 0. Minus 2 times, we calculate the second determinant. So 4 times 3, that is 12. 5 times 2, that is 10. Plus 3 times, again, we calculate the determinant for the last one. 4 times 0, give us 0. Minus 5 times 1, give us 5. So 1 times 3, give us 3. Minus 12 minus 10, give us 2. 2 times 2, give us 4. So here we'll have minus 4. And then the last one, 0 minus 5, give us minus 5. Minus 5 times 3 give us minus 15. And then 3 minus 4, that give us minus 1. And minus 1 and minus 15 give us minus 60. Okay, so this is by expanding using the first row. Let me again do this using a column this time, just to show you that we can get the same thing. So first, let me rewrite this. So this is the same matrix that we have above. Now let's say I want to use the second column. So again, it'd be easier just to put the sign. One way, as we did before, you can do the sign for the first, row, and then once you know the sign for the second element, you alternate for the rest. Or the other way, get the sign for the first element directly. So this is in first row and second column. So you add 1 plus 2, give you 3. This is odd. Odd give you minus. If it was even, it give you both. Then alternate the remaining. So the next one will be plus, then minus. Now we expanding using the second column. So again, we take the first element in that column, minus 2 time. Again, we create a determinant by eliminating the column and the row for that element. So you get 4, 2, 5, and 3. Then you take the second element in the column, which is 1 time Again, eliminate the row and column for that element. So what we'll have 1, 3, 5, and 3. Then the next one is 0. Now, 0 is a good element because 0 multiply with anything. It doesn't matter what's that value, it will be 0. So we don't really have to do a lot of work in this case when we have a 0. So now let's calculate these. Minus 2, let's calculate first determinant. 4 times 3, 12. 5 times 2, that is 10. Plus 1 times, the second determinant is 1 times 3. 3 minus 5 times 3, that is 15. So 12 minus 10 give you 2. 2 times minus 2 give us minus 4. 3 minus 15 give us minus 12. Times 1 give us minus 12. So minus 4 and minus 12 give us minus 16. And this is exactly the same thing that we get here. So we get here minus 16, and here we get minus 16. As you can see, regardless of which row or which column you use, you will always get the same answer. And you will notice that when we use the second column, because we have a 0 on the second column, that simplifies our work. So this is always something that you look for. You always look for a row or a column that have the largest number of zeros. And this strategy can always use it for larger sizes. So let me show you example with a 4 by 4 matrix. So let's have this matrix 1, 0, 3, 4, 5, 0, 0, 3, 2, 1, 6, 2, 3, 0, 0, 1. So this is our matrix. This is 4 by 4. Again, we can use exactly the same strategy that we used for 3 by 3. We need just to pick a row or a column. As we just mentioned, that it will be always better to use a column or row that have the largest number of zeros. The second row here have 2 zeros. The fourth have 2 zeros. The second column have 3 zeros actually. So this is the best choice because it have the largest number of zeros. So to do that, let's add the signs. So let's look at the first element on that column. So this element is in row 1 and column 2. 1 plus 2, that is 3. This is an odd number. Odd number give us negative. Then alternate. So the next one will be positive, the next one negative, then positive. So now let's expand using the second column. First one is 0, so we don't need to do anything. Second one is 0, don't need to do anything. Then the third element will be minus 1 time. Again, we have to get determinant by eliminating that row and that column for that particular elements. So in this case, once we eliminate the third row and second column, what you will get is 1, 3, 4, 5, 0, 3, 3, 0, 1. Then the next one is 0, so we don't need to do anything. Now we ended up with a 3 by 3 determinant. So again, to calculate this, we can use exactly the same strategy by using the cofactor expansion. And looking at this 3 by 3 matrix, we can see that the second column also have 2 zeros. This is the largest number of zeros, so we can use it. Then we add the sign. We start by adding the sign. So for the second column, the first element is in row 1 and second column. So 1 plus 2 again, that is 3. Odd number means negative. And then alternate plus minus, although actually we don't need them because these are zeros. Then let's expand this. So we have the minus 1 that we have before. And then to expand this, we take the first element in the second column, which is minus 3 times. Now we again need to create a new determinant by eliminating the row and column for the minus 3 element. So if we do that, we get 5, 3, 3, 1. So then you will get here minus 1 and minus 3, that give us 3 times. Let's calculate the value of this determinant. So 5 times 1, that give us 5. 3 times 3, that give us 9. So we have 5 minus 9, which is minus 4. Minus 4 times 3 give us minus 12. And this is the value for the determinant. So you can see it doesn't matter actually the size. You can always repeat the same thing. Pick a row or a column and then add the sign. Then take each element and you multiply it with the determinant that you get by eliminating the row and the column for that particular element. You may add up with another determinant of larger size, for example, like we have in this example, 3 by 3. Again, repeat the same process. Unfortunately, you can see that this method by using the cofactor expansion become tedious when the size become larger. Here in this particular example, we have a lot of zeros, so relatively it was a bit easy to calculate, but in general case, when you don't have a lot of zeros, this becomes a very tedious. So there is another way to get the determinant using row operation, and I will be making a video about that, so stay tuned. Finally, if you find this video useful, please give it a like and consider subscribing to the channel and turn the notification on so that you get notified about new content. Thank you for watching.